So let's look at dividing polynomials. So some of you might be able to start canceling out pieces right away here, but canceling out too early can lead to more mistakes. So if you want to be careful with your work, what I would recommend doing is separating this up. So what I mean by separating it, it's that each term gets this denominator of 2x, so that's dividing absolutely everything. So what I could do is rewrite this as 10x to the 5th over 2x, and then minus 8x cubed over 2x, plus 4x squared over 2x. So then with that, you can really see how 2x will divide into each little piece. So 10 divided by 2, so that's just going to leave us with 5. 8 divided by 2 is going to leave us with a 4. 4 divided by 2 will leave us with 2, so we get our numerical coefficients there. And then we have our exponent rules, so you can think of this as a 5 minus 1. So we'd have x to the 4th, or you can think of it in terms of cancellations, a few ways. But basically that x in the denominator will cancel out. Instead of an exponent of 5, we'll have a 4. For the next term where we have x cubed, we're taking one of those x's away, so we'd have x squared. And then where we have x squared, taking one of those x's away, that will turn into an exponent of 1. So for our first term, we're left with a 5, and then x with an exponent of 4, minus 4 times x with an exponent of 2, and then plus 2x with an exponent of 1. Alright, same idea here, just with more variables. So 2x cubed y to the 4th over 10xy minus 4x squared y squared over 10xy, and then plus 6x squared y over 10xy. So for the first term, the 2 divided by 10 would turn into a 1/5. 4 divided by 10 would lead to a 2/5. Leave that 5 up front. 6 divided by 10 lead to 3/5. Just reducing the numerical parts there. Alright, then for our variables. So x cubed divided by x, so that x will cancel out, but that would leave us with an exponent of 2. Y to the 4th divided by y, so 1y will cancel out, so we'll be left with y cubed. So in my numerator there, we have x squared, we have y cubed, and then all over, and all we have left in that denominator is a 5. For our next term, we have x squared divided by x, so that would leave us with 1x left over. Same thing with y. So in the numerator, let's see, we have minus in between them. We have the value of 2. We have 1x and 1y all over 5. And then plus, and canceling out, let's see, x squared divided by x, so that would leave us with 1x left over. Y divided by y is just going to turn to 1, so those y's completely cancel out. So with this piece, we have a numerator of 3 times x, and then in the denominator, 5. Now we could leave it just like that. If you wanted to, you could combine it back into a single fraction, since they all have the same denominator. So I could then combine it to be x squared y cubed minus 2xy plus 3x all over 5, and that would be correct as well. What could be nice about putting it back into this form is if there were like terms, you could simplify further by combining like terms. In this case, there aren't any like terms, so it would stay just like that. Alright, with this piece here, I'm going to change this into a horizontal format, vertical. So what I mean by that is having that x squared plus 3x plus 2 in a numerator, and then x plus 1 in the denominator. Now, when we have these strings of addition and subtraction starting to come through, especially in the denominator, we have to be really careful. Especially with the denominator, what I like to visualize are these parentheses that are grouping that x plus 1 together. It's gluing them together, it can't be separated. So what I mean by that is that we can't start canceling out x values because it's grouped together with that plus 1. How this differs from the examples we just looked at is that in the denominator, there wasn't any addition or subtraction in these cases. It was just a bunch of multiplication, and with that, there's a lot more freedom with that. If there's addition and subtraction in the numerator, that's not too bad to deal with because that just helped us separate the individual terms. But having addition, subtraction in the denominator tends to make things more difficult, so we just have to be extra careful that we don't start canceling things. Essentially, to cancel anything out from the denominator right now, it needs to be this entire x plus 1. So what we can do is to simplify this, factor the numerator. So what this would be is an x plus 1 times an x plus 2 all over x plus 1. I'm going to keep those parentheses there. And then I can see that I have this entire x plus 1 divided by x plus 1, and that'll get us cancellation. And then all we'll have left over is x plus 2. Let's look at another example with this. So 5x squared plus 7x minus 6 all over x plus 2. Again, I want to imagine these parentheses around that x plus 2, and that all I can cancel out is this entire expression of x plus 2. Now, let's do some side work here to get a factored form of that 5x squared plus 7x minus 6. So, a little refresher of the AC method. So 5 times negative 6 is negative 30, and I want to find two factors of negative 30 that add up to positive 7. So that's going to be a negative 3 and a positive 10. So two numbers that multiply to negative 30 and add up to the positive 7. So with that, I'm going to have 5x squared, and then this gives me a way of separating up that positive 7x. So I'm going to have a minus 3x plus 10x minus 6. And then we can factor by grouping. So on the left-hand side, we have a common factor of x, which would leave me with a 5x minus 3. And on the right-hand side, there's a common factor of positive 2, leaving me with 5x minus 3. So I can factor out that 5x minus 3, and my leftovers would be x plus 2. So now I can go back to my equation and plug in this factored form of 5x minus 3 times x plus 2. And now we can cancel out that x plus 2 because we can see it as its own factor. And then we'll just be left with 5x minus 3. Now this piece is touching on rational expressions. So those tied together, that rational expressions are the division of polynomials. So we'll be seeing more of those soon as well.